Hello, we are Ana González González, Cristina Aguirre Gallardo, and Galilea de León Delgadillo, and we have chosen to explain the topic of the course called Hypothesis Test. First of all, we will explain the background to understand what this is. In the hypothesis test, we have two types of hypotheses. The first one is called null hypothesis, which is related to the confidence interval. This is the hypothesis we don't reject. And the second one is called alternate hypothesis, which is related to the significance level. And this is the hypothesis we reject. In hypothesis test problems, we can find three types of cases. Let's remember that the problem will give us information about the population, the sample, the significance level, and the confidence interval. For the population and the sample, we are usually going to have the mean and the standard deviation. So, when our null hypothesis says that the mean of the sample is equal to the mean of the population, our graph is going to be two-tailed. When our null hypothesis says that the mean of the sample is greater than the mean of the population, our graph is going to be left-tailed. When our null hypothesis says that the mean of the sample is smaller than the mean of the population, our graph is going to be right-tailed.
Now we're going to see an example. The problem says, contingency phase 1 is declared active in Mexico City when the quality of the air surpasses 200 IMECA points. If there is a sample of 50 places in the city with an average of 219 IMECA points and a standard deviation of 90 IMECA points, should the contingency phase 1 be declared active using a confidence interval of 95%? The first step is to place the data we have in a table. It says that the mean of the population is 200 IMECA. Then the sample size is 50, the mean of the sample is 219 IMECA, the standard deviation of the sample is 90 IMECA, and that the confidence interval is of 95%. As we know, the confidence interval and the significance level have both to add up 100%. So if we know that the confidence interval is 95%, we can know that the significance level will be 5%. We have to analyze what the problem is saying. Now, according to what the problem says, if the mean of the sample is greater than the mean of the population, we need to activate phase 1. If the mean of the sample is equal to the mean of the population, we don't activate phase 1. And finally, if the mean of the sample is smaller than the mean of the population, we don't activate phase 1. As the two last statements say we don't activate phase 1, we need to gather them in a single statement. Now we have to identify which is the null hypothesis and which is the alternate hypothesis. The way to identify the null hypothesis is that it will always be the one including the equal symbol. Remember what Galilea explained about the tails? Well, as in this problem the null hypothesis says that the mean of the sample is smaller than the mean of the population, we can already know that our graph is going to be right-tailed. Now, we will go to the third and fourth step to know if the null hypothesis is rejected or not rejected.
To know if we need to use Z or T, we have to know if we have sigma. If it is given, we use directly Z. But if it's not given, we need to use the standard deviation of the sample. Then we have to analyze the value of N. If it is smaller than 30, we have to use T. But if it's greater or equal to 30, we use Z. In this problem, we don't have sigma, but we do have the standard deviation of the sample, which is 90. Now we analyze our n. As it is 50, that means we need to use z. First, to get the value, we will use this formula. If we substitute our values, we will have 219 minus 200 divided by 90 over the root of 50. The result of our calculated value will be 1.49.
Second, we will get the table value. To do that, we need to know the value of alpha. In this case, alpha is 0.05. So what we need to do is to take our sheet with the name Standard Normal Probabilities and look for 0.05 inside all of the number in the table. As we can see, it is located in the row minus 1.6 and the column 0.04. So if we gather these two values, our result would be minus 1.64.
But we need to remember that our graph is right-tailed, so this negative value turns into positive as our tail is in the positive part of the graph. We have to know that the table value represents the limit where the tail starts, and the calculated value is a point that can land in any part of the graph. Now, to know if the null hypothesis is going to be rejected or not, we have to pay attention where the calculated value lands. If it lands inside the part of the alternate hypothesis, it needs to be rejected, but if it doesn't, it does not have to be rejected. The last thing we need to do is the conclusions. There are three things we need to consider: math conclusions, qualitative conclusion, and confidence interval. For math conclusions, we reject or don't reject the null hypothesis. For qualitative conclusion, we demonstrate significance evidence to support the answer. And for confidence interval, we use the following formula. For the problem conclusions, the math conclusion would be we don't reject the null hypothesis. For qualitative conclusion, there's significant evidence to say that it's not necessary to activate phase 1 alert. And for the confidence interval, the answer is 220.8. Overall, in order to solve a hypothesis test, first, we need to find data. Second, we need to establish a hypothesis. Third, we need to know if we use Z or T. And at last, we make conclusions.